we're going to graph a transformation of cosecant. What I would do is graph a transformation of sine, and then there's just one extra thing at the very end. If you remember graphing sine, we can start by drawing the midline, and the midline is going to be up 1, and it's not shifted left or right, so it's going to start right at 0. And the length is the period length. The period is based on this b value. The period for sine, cosine, cosecant, and secant is 2 pi. So we're going to do 2 pi over 2, which is pi. And that is going to be the length of one cycle. So I'm going to extend my line all the way to pi. Then the amplitude in this case, if it was a sine graph, would be 2. Even though it's cosecant, we're going to pretend like it's sine right now. So it's going to go up 2 and down 2. And then we can plot our sine points in there. And it is reflected, so we have a point at the beginning, middle, and end of the midline. But then at the bottom of the box will be a point for the first quarter, and the top will be a point for the third quarter because it was reflected. So that would be if the problem was -2 sine of 2x plus 1. But now, because it's cosecant, what we need to do is every time it hits the midline, there's going to be an asymptote. And I'm just going to keep extending that. Every 2 dash marks was another asymptote. And then every time we had a min on the sine, that's going to be our max for a little parabola for cosecant. This was a max. That's going to be a little min for the parabola. And then it's just going to keep alternating. And there's a transformation of cosecant. You can do the same thing when you're transforming secant. Just draw the cosine graph and then draw your asymptotes where the cosine hits the midline. And then anytime the cosine has a relative max, that's going to be a relative min. And anytime the cosine has a relative min, it's going to be a relative max on the secant.